This video is about partial fractions and integration. The process of integrating partial fractions is really simple, but creating the partial fractions is the part that's a little bit difficult. You learned in pre-calculus how to do this, but it may take a bit before you remember having learned this. So we're going to start off with x plus 18 divided by 3x plus 5 times x plus 4, and we're going to split this into two parts. We're going to have one fraction with the denominator 3x plus 5 and one fraction with the denominator x plus 4, and we're going to put an a and we're going to put a b. So the process of partial fractions is figuring out if we were able to separate this to where one part goes with this denominator and one part goes with this denominator, then we would be able to do a lot more with it. So I call this a complex fraction, and complex fractions don't easily separate until you go through this partial fraction process. So first of all, you just write the two factors separately, and you use the a and the b, and then what we're going to do is we're going to multiply everything in this equation by 3x plus 5 times x plus 4. In other words, that's hard to see in there. In other words, we're taking this denominator right here. We want to take it out. So what you're going to do is take x plus 4 times 3x plus 5, and we're going to distribute it to each of these fractions. So when I multiply this fraction on the far left, well, the denominator is going to completely cancel because this will be in the numerator and it will cancel, that will cancel out the denominator. So I'm going to have x plus 18. Now when I do this one right here, the 3x plus 5 part will cancel, but the x plus 4 part will not. So I'll be left with a times x plus 4, and then when we multiply by this part here, we will have the x plus 4 part cancel, but not the 3x plus 5 part. So that's going to be our basic first step. And then we're going to do some simplifying. So I have x plus 18 equals ax plus 4a plus 3bx plus 5b. So just distributing stuff out. And now I'm going to regroup this. X plus 18 is equal to, and what I'm going to group together are the x parts, which are ax and 3bx. So ax plus 3bx. I'm going to group those two things together. And then the parts that don't have x, which are 4a plus 5b, I'm going to group those parts together. The reason I'm doing that is because on the left side over here I have 1x, and on the right hand side I have ax plus 3bx. So if I factor the x out, it'll be a plus 3b in front of that x. So the number in front of this x, since it's an equation and they're equal, that number here, which would be a 1, has to be equal to a plus 3b. And then also, the 18 on the other side, that's the constant on that side. And since this part on the right side does not have an x, that makes it the constant. So that means that those things are equal. So I'm going to write a plus 3b equals 1. And I'm also going to write 4a plus 5b equals 18. Okay, double check myself. Okay, so what do we do with this? Well, we have a's and we have b's, and we have equations, and this is actually a system of equations, so we can either use substitution or elimination. And I would say probably our best case scenario here would be to go ahead and use elimination. So let's multiply by negative 4 on the top here. So that's going to make this become negative 4a minus 12b equals negative 4. And this bottom part here is still 4a plus 5b equals 18. when I add these straight down, the 4a's will cancel. I'm going to be left with negative 7b equals 14. Divide by negative 7, and my b is negative 2. So, now that I know that b is negative 2, I'm going to go and substitute back in. So I'm going to use this one up here and have a plus 3 times negative 2 equals 1, because that was the original equation. So a minus 6 equals 1, so a equals 7. So now I'm going to go back where I split my fractions. I'm going to go back to that spot, and I'm going to put 7 for a and negative 2 for b. So 7 is going to go where my a was, and negative 2 is going to go where my b was. So what we did is now we have taken this equation and we've changed it to be this equation. And this is going to be much simpler to integrate, because we're going to integrate 7 over 3x plus 5 minus 2 over x plus 4. So let's find some space to write this out. And okay, so we're going to write these things out. 7 over 3x plus 5 minus 2 over x plus 4. That is our new integrand. We've replaced the old integrand because we separate this. And now we're just going to separate it into the two parts that we have. 7 over 3x plus 5 minus the integral of 2 over x plus 4 dx dx. In both cases, I'm going to take the constant on top out. So on this side we'll have 1, and on this side it's going to be, the 7's going to be gone. And now you have to look to see this is actually going to fit the format for ln. So I've got my dx, which is technically in the numerator, and my denominator is 3x plus 5, so the derivative of 3x plus 5 would be 3 dx. So if I put a 3 in, I have to balance it on the side. On my second one, the derivative of x plus 4 is 1, so it's already there, so we don't have to balance anything. So 7/3 natural log 3x plus 5 minus 2 natural log x plus 4 plus c. That's my solution to the integral. Okay, I have one more example. The nice thing about the AP test on this type of situation is that they only do a certain type. And so as long as we can break this into two factors, we've covered what we need to know. So we don't have to do a whole lot of practice with this. Alright, x squared minus 6x plus 5. Let's break this into x minus 5 and x minus 1. So 4 over x minus 5 times x minus 1 equals a over x minus 5 plus b over x minus 1. And I'm going to multiply this whole thing through by x minus 5 times x minus 1. When I distribute it over here, it's going to cancel. When I distribute it to the a fraction, the x minus 5s are going to cancel. When I distribute it to the b fraction, x minus 1 is going to cancel. There we have a much simpler problem to deal with. Let's go ahead and distribute. Ax minus a plus bx minus 5b. I'm going to go ahead like last time, and I'm going to group my ax plus bx. But I'm going to go ahead and kind of skip a step here. Ax plus bx, so let's do a plus b, parentheses x. We'll just factor that x out as we write it. Then I'm going to have negative a minus 5b, and I can immediately look and see what will these be equal to. On the left side there is not an x, so we're going to pretend, or we're just going to write it so we can see what it would look like. It would have to be 0x, so a plus b has to be 0. And negative a minus 5b has to be 4. So I'm going to write a plus b equals 0. And I'm going to write negative a minus 5b equals 4. I'm going to double check myself, make sure I got everything right. And then this time I'm going to use substitution, because when you have a plus b equals 0, we just move the b on over, and we know a is going to be negative b. So if I make that substitution here, negative a, so negative b minus 5b equals 4. So 2 negatives makes a positive. B minus 5b is negative 4b. B is going to be negative 1. If b is negative 1 and a is going to be the opposite, a is going to be positive 1. So we're integrating 1 over, what is it, x minus 5 plus negative 1 over x minus 1. That's what we're going to integrate now, once we found our a and our b. So I'm going to go ahead and put the dx up here. With partial fractions, it's pretty much always, it's kind of a given, it's going to be a natural log problem. So I'm just going to double check this and see. X minus 5, the derivative of x minus 5 would be 1. So I got my 1 dx. So that is the natural log of x minus 5 right there. On this side over here, I could just take the negative out. So the derivative of x minus 1 is 1 dx. Now that the negative is out here, I can do minus ln absolute value x minus 1 plus c. And then I'll go ahead and show you right here. This is one of those times they might bring the logarithm together, because it would be very easy to say this is the natural log of x minus 5 divided by x minus 1 plus c. That is definitely something you could see as an answer choice. So that's the method of partial fractions, and there's a worksheet for some practice problems.